Hello everyone, welcome back to Astrox Radio. This is the weekly podcast hosted by Astrox on my YouTube channel, which is also available on audio platforms like Spotify and Pocket Casts. This episode, we're going to be diving deep into the first Artemis Moon Base and what it will be like to live in it, what it will look like, and how it will be constructed. Let's jump right in.
Ignition, engine start, and that's liftoff. Welcome to Astrox Radio.
First, let me mention that the Artemis 2 crew, who has recently launched, has completed their lunar flyby. And if all went to plan, they splashed down before this episode was uploaded, but it was after I recorded it. So let's actually get into the topic. We'll first start with what it will look like. The Artemis Moon Base camp will likely sit near the moon's south pole, as it will be chosen for sunlight and ice access. They want that ice access to get water, and that sunlight's crucial, as in some spots you get key amounts of sunlight, as there's constant sunlight around there. It will include habitats, a power system, a rover garage, and communication arrays spreading across a small lunar plain. So the habitats will be these like tube-shaped modules, or maybe even starships. They haven't confirmed that yet. But if it is tube-shaped modules, they would be connected by these little bridge airlock parts, and there would be airlocks to exit into the lunar surface. As well as I said, there was rover garages. So there would be garages where rovers are stored that can traverse the lunar surface without using too much of the astronaut's energy. And for communication arrays, it will be similar to how there will be solar arrays, where they'll be put on tiny little poles and lifted into the sky so that they can have the best communication with satellites above, while also for solar arrays, they would have the best access to sunlight. The best expectation is for a metallic modular structure, where there would be inflatable units joined together, which are partly covered with lunar dust to block radiation. So inflatable units, you may ask, why are they doing this? If you've heard of the Orbital Reef space station, which I talked about space stations in the last episode, the Orbital Reef idea is made by Blue Origin and Sierra Space. Sierra Space is working on inflatable modules, which means some parts of the living area of the space station is inflatable. So you just need air to pump it up. So they might be doing that on the moon. But as I said, all of this is to be confirmed. And then about the lunar dust. The lunar dust, if it's over the inflatable modules, it can block the radiation rays coming from the sun, as there isn't an atmosphere or a magnetic field on the moon. So a lot of solar radiation will come through. Next, we move on to life inside the base. Astronauts will live in compact but high-tech quarters, with life support which will be recycling air and water almost completely. This is crucial, as they won't get tanks of oxygen and tanks of water coming up to the moon maybe every week or so. They need to have it recycling almost completely, just like they're doing on the International Space Station, as it's hard to have continuous transports of life support going always to the moon, so they have to do something that's self-sustainable. Inside the base, there would be artificial lighting, which would mimic Earth's day-night cycle to help with sleep and mood. This is because the moon has a 14-day night period and a 14-day day period, and it's really messed up. So as the crew would be humans, they want to be used to their usual day-night cycle. And the typical stays could range from 1 to 2 months, but it would be increasing as the base would grow in capability. Next, we move on to how it will be constructed. Early missions like Artemis 4 to 6 would ferry modules via SpaceX's Starship HLS and lunar landers like Blue Origin's Blue Moon. There'd be robotic systems and possibly autonomous rovers which will pre-build foundations and solar arrays. Like the solar arrays I said that are hoisted up into the sky. Future structures might use in-situ resource utilization, where there'll be 3D printing walls using lunar regolith. So in-situ resource utilization is basically they get the moon rocks and dust, so regolith, and then they use that to build their bases. Kind of a cool idea, don't you think? Moving on to cost and partnerships. NASA would lead in the funding, with major roles from SpaceX, Blue Origin, Lockheed Martin, and international partners like ESA and JAXA. The estimated cost is tens of billions of United States dollars over a decade, which is roughly similar to the International Space Station investment levels. But much of that cost will be offset by shared research goals and reusable systems. It's all about their daily routines and challenges. The crew will balance research, maintenance, and exercise, which will be done for 2 hours daily to fight muscle and bone loss. This is key, as the crew won't be operating in full Earth gravity, as their bodies are built for Earth gravity, which is 1g, but the lunar gravity is 1/6 of that. So they need to exercise for more than 2 hours daily so that their muscle and bone loss does not increase in space. There will be communication with Earth, which will have a 2.5 second delay, which will make autonomy and decision training essential. And for this psychological support, it will be done through VR, with Earth video calls and scheduled social Earth windows, where they can have faster communications if they're facing towards the Earth. And there's always the science. And also, what's the goals of this mission? Why are we going to the moon in the first place? We're going to the moon to test deep space survival for future Mars missions. The moon counts as deep space. Most people don't understand how far away the moon is. So envision this. The International Space Station is orbiting Earth at about an orbit of 400 kilometers high in low Earth orbit. But the moon is 400,000 kilometers away from Earth, a whole nother scale. They'll be conducting geology, ice mining, and solar power experiments, which will be very useful to future space missions. It'll be acting as a hub for robotic missions and future space tourism prototypes. Imagine you going to Fiji or the Bahamas for a trip. Just imagine that. Okay, now imagine you going to the moon for a trip. Whole nother story, but it can be possible within the next century. Once again, we're doing Did You Catch the Cosmic Update, which is a trivia segment I invented recently for my podcast. Question 1. Where will the Artemis base camp likely be built? A. Lunar equator. B. Moon South Pole. C. Near the Sea of Tranquility. The answer is the Moon South Pole. Question 2. How long might early astronauts stay at the base? A. A week. B. 1 to 2 months. Or C. Over a year. The answer is B. 1 to 2 months. Question 3. What material might future structures use for 3D printing? A. Martian soil. B. Aluminum sheets. Or C. Lunar regolith. The answer is C. Lunar regolith. So now let's just look ahead. The key idea of this is that the first Artemis base isn't just going to be a station. It's going to be the first step towards long-term human presence beyond Earth. And don't forget about the Artemis 2 crew, who would have splashed down in the ocean before this episode was uploaded, and the anticipation coming for Artemis 3, which I'm really excited about, knowing that it's going to be the first testing of HLS, which is a human landing system Starship, and the Blue Moon lander in low Earth orbit, or whichever one is available first. Which then there will be Artemis 4, which will land on the moon, and I bet you there will be so many viewers of that. Also, fun fact, do you know that the Artemis 2 livestream of the crew going around the moon got over 25 million views, making the most viewed livestream ever in the history of NASA's YouTube channel. So if you like this episode, can you give me a hand by subscribing to me on YouTube and following me wherever you get your podcasts? Join my subreddit, which is r/Astroxia_SRT. Make sure to keep looking towards the stars and blast off. Thank you.